Hello everyone. In this video, we are going to see how to solve add two numbers problem from LeetCode. To solve this problem, we'll be getting two linked list as an input. The constraint to the linked list will be each node value of the linked list can contain only single digit and that two will be non-negative integers. You can see the constraints in the below. The number of node, the depth of the linked list can be of between 1 to 100, but the value of each node should be between 0 to 9, meaning it should be single digit and it should be positive value. And the linked list will not start with 0 when it is having more than one value. These all are the constraints. By seeing this code, this is the code to generate one node for our linked list. You can see it is having two properties. One is val and another one is next. Val is to refer the value of the node and next is to refer the next node reference. By seeing this, we can say this is a singly linked list because it doesn't contain any value to refer previous node. To solve this problem, we have given three test cases. We can consider these examples as a test cases. The first case is both L1 and L2 is having same length of node. Both the input linked lists are having same length of node. The first linked list is also having three nodes and second is also having three nodes. In the second case, both are having same length. In this case, maybe one, but both are having all the nodes as zero. And the third case is the L1 and L2 is having different length of node. In this case, L1 is having some around seven nodes and L2 is having only four nodes. So when we try to solve this problem, we need to consider all these test cases. Now we'll try to find the approach to solve this problem. With the help of this first case, we'll take the first example inputs. One is the first list is 2, 4, 3, and the second linked list is 5, 6, and 4. 2, 4, 3. Yeah, we are going to find a basic arithmetic addition operation against these two lists. So when we add 2 and 5, this is the beginning position of L1 as well as L2. When we add up 2 and 5, we'll be getting 7. And we are done with the first position of L1 as well as L2, so we need to move to the next position of L1 as well as L2. And even this is our result linked list. Even in the result linked list, we need to move to next position. So in the next position, we have 4 in L1 and 6 in L2, where when we add them up, 4 plus 6 will get 10. But as per our linked list constraint, we should not have more than one digit as a node value. So to avoid that, we are going to keep only one digit in this position of result, and we are going to keep that remaining one as a carry forward value. This is basic arithmetic operation. So we now move to the next position in L1, L2 as well as in result node. So we are going to add them 3 and 4 will be 7, and we are going to add the carry forward value which is 8. You can see this is our result node. For this use case, you can see 708 is our result node. This is what we are going to achieve in our programming. So we are going to loop through each node of L1 and L2, and we are going to operate arithmetic operation. And if any carry forward value is there, we are going to take that to the next position and consider in that position. That's it. So we'll start implementing that. We'll create one variable called result node to hold our result linked list. I'm going to initialize with list node of 0. This list node is a function that is provided. It can take two argument. Initially, when I pass 0, that will assign 0 to this val, and next will be undefined. Next reference will be undefined. That's it. Now we are going to loop through our elements of linked list, nodes of linked list maybe, until both L1 and L2 is having value. That is because in the first case, both are having same length. So if L1 is having value for that position, L2 will also have the value for that position because both are having same length of node. So until L1 and L2 is having value, we are going to loop through and we are going to find the sum value. Sum is nothing but the accumulation of both the node value. L1 value will be like this, L1 dot val and plus L2 dot val. But we also found that there could be some carry forward value. This sum may have more than one digit also. In that case, we need to hold this carry forward value in one variable. For that, we are going to create one variable called carry with initial value of 0. So every time when we perform this sum operation, we are going to consider this carry value. Initially, it will be 0. In this position, carry value will be 0. In the next position, if any carry value will be there, we need to assign. So we need to calculate this carry value in the next position. So the carry value will be more than, if the values, some values containing more than one digit, the digit after in the 10th position will be the carry value. So for that, we are going to do carry equal to sum divided by 10. So when we do this, we'll get the digit which is in the 10th position. Maybe we'll put it inside the percent to avoid nan. Now we found the carry. Now we need to find the value, current node value. To do that, maybe I'll create another variable, current node value. We need to find only value after this carry in our digit, right? So we are going to do the mod operation. When we do this mod operation, we'll get only one digit which is exclusive of this 10th position, which we already carried in our carry variable. Now we got this value. Now we got the result node, first result node value. We are going to initialize our result node dot next, because that will have the 0 value, will have a 0. We are going to initialize the next node of result node as new list node with this value, current node value. Now we have completed one iteration. So now we found this 7 in our result node. Now we need to move to next position in both L1 as well as L2, as well as in result node. We need to move to next position. We are going to do that by assigning L1 equal to L1 dot next, because next will always reference the next node in the linked list. Then L2 will be L2 dot next. We need to do the same for result node also. Result node equal to result node dot next. That's it. So we are just finding, maybe we'll do the sum, and we are finding the carry value, and we are finding the current node, and we'll put, maybe we don't need a separate variable for this. We are going to put it directly here, parse int this. So we are preparing our next node, and we are moving to the next position. That's it. Now we are going to return our result node. Now you can see our result node position is keep moving. In this example also, the result node first it will point to this position. In the next iteration, it will move to this position, and in the next iteration, it will go to this position. So if we just return the result node at the end, it'll of course it will point to the last position of the result node. Only we'll get that will be returned. But we need to return the beginning of this result linked list. So to hold that beginning position, we need another variable that we are going to name it as head node, because head will always reference the beginning node of the linked list. Instead of returning result node, we are going to return this head node. And you can see when we start assigning our first result node, we are starting from next one. So instead of returning the head node, we are going to return the head node dot next. That's it. We'll try to run and see. You can see now two cases are passed. This first case and second case, where we have the same length in both the linked list, are passed, but it is failed in third case, because this loop will happen until both are having value. We have used and, right, L1 and L2. In this case, where L1 is having around 7 node and L2 is having only 4, it will loop through and only till 4 indexes. You can see until 4. That's why we got output result node only with 4 nodes. It did not, the loop did not continue after fourth node. So we need to handle that. To do that, so this loop will handle until the same node length between L1 and L2. So we are going to have another loop. If L1 is, after exiting this loop, if L1 is still there, if it is not becoming null, then we can see L1 is having higher length. So we are going to do the same inside this also, and in this case L2 will not be there. because either of one input linked list only will have value. If it is having same length, then it will be covered in this loop only. If either of one only will have value when it come out of this first while loop. So if L1 is having value, we are going to consider only L1 value and carry, and we are going to do the same for rest of the thing, and there is no need of L2 to move to the next position. That's it. Similarly, if L2 is having value, we are going to do the same. L2, similarly L2, and we are going to move only L2. That's it. Now we will run and see. Still the third case is failed, but you can see our output is now changed. Now it is containing some other digits also. Now it is containing this, but it didn't have this last one. That is because this one will come as a carry forwarded value. We'll take this both the input, and we'll see in this way. We'll take this and we'll take L2. If we try to apply addition formula, 9 plus 9 will be 18. We'll put 8 and 1 will be carry forward here, and 9 plus 9 is 18 again. 18 plus 1 will be 19, so we'll put 9 again. 1 will be carry forward in this position. 9 plus 9 is 18, and plus 1 will be 19. Again 1 will be carry forward for this position. Again 9 plus 9 is 18. Then by adding 1 it will become 19, so we'll have 1. Then we'll have carry forwarded 1 here. So 9 plus 1 will be 10, so we're going to have 0 here. Then 1 will be carried forward to this position. 9 plus 1 again 10, we'll have 0. Then we'll carry forward the 0 to this 1 to this position. Again 9 plus 1 will be 10, so we'll keep 0. Then we'll move, then we'll have that remaining one in our carry variable. So till this we got it, but the carry variable is holding the last one. So we need to consider that also. That is what we are going to do in the last. So after all this loop is completed, if carry is still holding value, if carry is greater than 0, we are going to consider that as a last node. We are going to consider carry as the last value. That's it. Now we'll try to run. You can see all the cases are accepted. But you can see there are a lot of while loops is there. We can just simplify this loop. We'll try to simplify this loop because inside all the loop we are trying to do the same, correct? So we'll put all inside one loop, so we can make it as a R, and this R if carry. So we are putting all these condition inside one loop. But when we put all, this L1 sometime will become null or L2 will become sometime null. So we need to make sure it is not null. We need to make sure of this. Parsing, if it is null, put 0. Parsing, if L2 is null, put 0. We have already initialized carry, this will not become null. Parsing, okay. Then we have the same, okay, sum. And here if L1 is there, we'll move to the next position. If L2 is there, we'll move to the next position. That's it. And we can get rid of all these things. Hope this should work. Yeah, you can see all the test cases are passed with the simplified code. Yeah, that is all. We'll try to submit. This is the status. That is all I have for this video. Thank you for watching. If you like this type of content, please do subscribe and support me to grow this channel.